Hi, my name is Katie Griffith, and I have chosen to title my research The Starving Artist with a Full Mind, and this is a study of long-term memory in musicians. The way that I see it, music is an inescapable beat that we all form our lives around. Musicians are individuals who choose to immerse themselves in music through instrumentation. Too often, I believe musicians are only labeled as creatives or artists, and while they are these things, they are also intellects. They are the masterminds behind the soundtrack to each of our lives. Musicians are constantly learning new works that they must effectively and efficiently commit to memory. It is projected that musicians will have higher functional plasticity than non-musicians, and therefore will be able to more easily form and access long-term memories. The neural pathways developed by musicians through repeated retrieval and recall will preserve their musical memory and in turn aid in combating neurodegenerative diseases such as Alzheimer's. Hopefully, you will understand by the end of this presentation that making music is not just exciting, but educational and essential to brain health. This paper will demonstrate how musicians are more effective at forming and accessing their long-term memories than non-musicians. First, in order to understand the workings of a musician's brain, we must familiarize ourselves with the different types of memory that exist. The type of memory at work when remembering past experiences, either alone or in a group, is referred to by psychologists as autobiographical memory. However, this is only one task that the human memory performs, as the act of remembering the past demands many related functions to work in tandem. According to a study done by John Sutton in 2010, these capacities consist of, quote, motivation, language, and emotion, as well as the basic ability to store and retrieve information, end quote. Looking at the first graphic, we can see the umbrella of memory devolves into two subcategories, explicit and implicit memory, also referred to as declarative and non-declarative memory. The branch of studying neurocognition happened gradually following the study of a patient with an injury to their temporal lobe, unable to form new memories. Despite this patient's considerable amnesia, he still retained the ability to learn new skills, though he could not remember learning them. This finding helped researchers distinguish between declarative memory and non-declarative memory. With declarative memory, information can be consciously recalled and articulated. On the other hand, non-declarative memory is at work when an individual cannot articulate but can physically sequence these learned skills or behaviors. Non-declarative memory is also referred to as procedural memory for this reason, since one is remembering how to perform a task. Under the umbrella of declarative memory, we can devolve further into episodic and semantic memory. Episodic memory is processed in the temporal lobe and helps to establish a sense of self through the understanding of your experiences. This process is considered uniquely human and described as quote-unquote mental time travel by some theorists, as it allows one to psychologically relive a past event. Semantic memory, on the other hand, is conceptual and factual knowledge that is stored, but not in relation to a specific memory. A great example of this would be learning arithmetic. You know that 2 plus 2 is 4. However, you do not experience mental time travel to when you learned that fact. That is just stored in your semantic memory as a known fact. According to a study completed in 2010 by Dr. Groussard, there is a constant interaction between episodic and semantic memory during long-term memory retrieval in musicians. Now that we've explored what types of memories there are, we can move into the process of making memories. Memory is described in its most basic form as the process of information retention over time. It is an integral part of being human and allows individuals to recall past experiences in order to frame what is occurring in the present. How each individual perceives an event differs. However, there are three main processes that we all possess to characterize the workings of memory: encoding, storage, and retrieval. The repeated process of retrieval is a key in strengthening the long-term memory pathways of musicians. The first step is encoding. This is the primary process of forming memories, which is the learning of information. The step encapsulates how information is taken in, understood, and subsequently altered for easier storage. Information is encoded through four main methods: visual, acoustic, semantic, and tactile. When a musician practices their instrument, they utilize a combination of visual, acoustic, and tactile methods. Encoding, being the first step in the process of memory, allows it to set the tone for how information will then be stored and interpreted. The second part of the memory process is storage, which refers to how, where, how much, and how long encoded information is retained within the memory system. Encoded information is first stored into short-term memory and then in long-term memory if necessary. Atkinson and Shafran argue that information encoded acoustically will remain in short-term memory unless repetition occurs to store it in long-term memory. This can be easily connected to musicians. When first learning a piece, they are encoding in short-term memory, but the repeated practice encodes it into long-term memory, thus working out that long-term memory muscle, if you will. If new information does not receive the proper time and attention, it can cause information stored in short-term memory to be forgotten. This is because short-term memory is very finicky and only lasts between 15 and 30 seconds. This is why it is so crucial for musicians to practice their craft every single day. The system of short-term memory also has a low carrying capacity, only being able to store 5 to 7 items at a time. Oppositely, long-term memory has unlimited storage, so information will be stored there indefinitely. For purposes of this presentation and research, we will focus on long-term memory storage specifically. Retrieval is the process in which one accesses stored information. Information stored in short-term memory is recalled in the order that it was stored, such as a grocery list. Retrieving long-term memories happens through association. An example of this might be forgetting where you put your keys, so you mentally retrace your steps of walking into the house after getting out of your car. In order to capture the relationship between all three of these processes, Richard Atkinson and Richard Shifrin developed a diagram that has matured into the commonly known modal model, and this can be seen in Figure 1 on the slide. This illustration has provided the basis for contemporary cognitive models of memory. Now delving into the process of retrieval from long-term memory specifically, we must define working memory. Recently, researchers have acknowledged the complexity of tasks required by short-term memory to perform. As a result, the construct of working memory was developed. An example of working memory is remembering the words said at the beginning of a sentence in order to understand the end, something that we do quite frequently. Therefore, when we retrieve tasks from long-term memory, they are brought back to this working memory in order to be performed. On this slide, we're going to explore a study that deals with the structural and functional plasticity of musicians' brains as explored through fMRI technology. The unique training undergone by musicians to develop their musical skill results in certain modifications to the structure and function of their brains. One study conducted by Dr. Groussard and published in 2010 used functional magnetic resonance imaging, or fMRI technology, to explore the effect of musical training on brain activity during long-term memory retrieval. The change of function within the brain is shown in images that demonstrate stronger activation among musicians in the temporal complex, and specifically the middle temporal gyrus. The repeated rehearsal that musicians endure induces structural differences to the brain as well. In the central nervous system, white matter regions contrast with gray matter regions. White matter is seen as the channels of communication, and gray matter is where processing occurs. Looking at musicians versus non-musicians, the main differences can be seen with the enlargement of several brain regions within musicians. The study selected 20 musicians who had been playing music without interruption until the time the study was conducted, and 20 common listeners of music that were strictly non-musicians. Each individual was scanned by an fMRI while completing a music semantic memory task. They were asked to rate the familiarity of 60 melodies that were purely instrumental excerpts on a 4-point scale, 1 being non-familiar and 4 being extremely familiar. This task forced subjects to compare the music they were actively listening to with melodies stored in their semantic memory. In order to identify the brain regions associated with musical expertise during this familiarity task, researchers analyzed the effects of familiarity on cerebral activity based on the subject's response for each melody. The data collected demonstrated that non-musicians judged more melodies as non-familiar, while musicians judged more melodies as extremely familiar. In both groups, the fMRI demonstrated that familiarity with the music resulted in increased activity in the left motor areas of the brain and the hippocampus. This can be seen in the graphic on the screen, musicians versus non-musicians, looking at the left hemispheres specifically, with the musicians on the leftmost side and then the non-musicians on the rightmost side of the screen. Both of them have activity, but the musicians is much more active than the non-musicians. However, activity is still present in both. A debriefing session followed the study to gather whether the melodies played evoked personal memories or mental imagery for the subjects. It was revealed that excerpts elicited personal memories in 85% of musicians, but a mere 30% in non-musicians. Musicians noted that they could see themselves playing the melody as they were listening to it. This demonstrates how the pattern of activation within musicians combines semantic and episodic memory. As the music stored in their long-term semantic network is recalled, it evokes the images seen while listening to the music. The networks are working in tandem, thus building stronger retrieval pathways, which can in turn contribute to a greater cognitive reserve. The action of repeated retrieval undergone by musicians aids to reduce age-related decline in memory. In summary, the results of this study indicate that musical expertise modifies the long-term memory process, including the structural and functional plasticity of the brain in musicians. Pictured on this slide is Caroline Palmer, the research chair in cognitive neuroscience of performance and professor in the Department of Psychology at McGill University in Montreal, Canada. Her 1997 publication of Music Performance seeks to explore how people make music, from simple rhythms to complex ensemble performances. This is possible through the combination of cognitive and motor skills while playing. Palmer posits that speaking, typing, and performing music are among the most complex forms of skilled serial action produced by human beings. Theories of motor control commonly list performing music as the ultimate motor skill acquired by humans. The act of playing music is multifaceted and requires the performer to focus on multiple aspects at once. For example, if a musician lacks control of tempo, their performance is considered deficient because not all complexities are working in harmony. Temporal relationships must be present with the music for the sequence of notes being played to be considered accurate. This information suggests that musicians must be highly adaptable in order to survive in their field. The ability to perform music requires the correct marriage of motor control and the perception of tempo, melody, and pitch of a composition. Performing music is a unique human ability, possible with the non-unique underlying cognitive mechanisms that all humans share. The ability of musicians to utilize these cognitive functions in a way that allows for musical performance is what separates musicians' brains from non-musicians. On this slide, we'll focus on the preservation of musical memory, and specifically a study conducted by Jacobson and his colleagues in 2015 that centered on the idea that musical memory is somewhat independent from other memory systems. As a result, in Alzheimer's disease and different types of dementia, musical recognition remains surprisingly strong. The study was designed to compare the brain areas responsible for encoding long-known music with the anatomy of a brain with neurodegeneration caused by Alzheimer's disease. A 7T functional magnetic resonance imaging study was performed to analyze how the brain responded to music excerpts that were unknown, recently known, and long known. Through this work, Jacobson and his colleagues were able to identify the regions of the brain responsible for encoding long-term musical memory. The second part of the study analyzed the data of 3 essential Alzheimer's disease biomarkers, or warning systems that the human cell creates, in the regions of interest identified with the first part of the study. It was found that the regions in charge of recording musical memory experienced minimal disruption by these biomarkers. This work implies how crucial long-term memory is in preserving brains plagued by neurodegenerative diseases such as Alzheimer's. To wrap up, music and memory are both innately human, and the two work together in profound ways. Musicians surround themselves with music each day, essentially exercising the areas of the brain necessary to gain plasticity. The strengthening of these neural pathways allows for more efficient long-term memory retrieval. The work we discussed by Dr. Groussard in 2010 proves that musical expertise modifies long-term memory processes, including the structural and functional plasticity of the brain. Further, this is demonstrated in the 2-part study that we just discussed by Jacobson in 2015, centered around the prevention of musical memory despite the development of Alzheimer's. The arguments presented justify the importance of incorporating music into everyday life. The storage of music into long-term memory can aid in the retrieval of associated episodic memories. Further, this shows that musicians are less susceptible to neurodegenerative disorders, constantly strengthening the area of the brain responsible for musical memory. Musicians can also retrieve long-term memories more efficiently than non-musicians due to the repeated use of retrieval during instrumentation. The key to preservation of long-term memory networks is to surround oneself in music. Musicians immerse themselves in music and therefore develop stronger retrieval pathways compared to non-musicians, which ultimately aids in the prevention of neurodegenerative disorders.